morning and good afternoon. Thank you for joining us today. I'm your host, Rob Ham, and today we're going to be talking about synchronizing innovation and manufacturability. And joining us from RV Industries, an industrial equipment manufacturer in southeastern Pennsylvania, we have Pete Cagle and Alan Stoltzfus. Hey guys, could you tell us a little bit about yourselves?
Yeah, been with the company for 8 years now. Started with RV actually directly out of college. Was a welding engineer here, I should say, for 5 or 6 years. Ran the welding program and then transitioned into sales a few years ago. So I've been working in sales engineering for a couple years now.
And my name is Alan, and I'm a sales engineer with RV Industries. I've been with the company full-time for about a year and a half, but I started with the company back when I was going to college for a mechanical engineering degree, and I interned part-time, full-time summers for about 3 years in a variety of roles from design engineering to manufacturing engineering, and got a good perspective to kind of move around in some different areas of the company before eventually post-graduation settling into more of the sales side.
Thanks, guys. It's always a pleasure talking with people who have a passion for what they do. And I'm looking forward to today's topic because it's really going to benefit engineers and designers who are in an early design phase of either a new product line or new project specific to the industrial equipment industry. So let's jump right in. Pete, you have an excellent background in manufacturing engineering. Could you share with us, when it comes to material selection, what should be considered when selecting the right materials for your project?
Yeah, so for us as the fabricator, we don't know what, exact chemicals or loads or environment that the equipment that you're designing is going to be in. Our primary goal is to make sure that the conditions of the material are still there, be it corrosion resistance, strength, when we're done processing the material and building the components. The big factor that we really like to try to assist designers with is, manufacturability, purchasing, commodity availability, especially when you get into some of these high alloys where, there might not be a specific high grade alloy coupling or flange sitting on a shelf somewhere that you're trying to design this part out of. So, that's really where giving someone like ourselves who has worked through purchasing, has worked through making parts out of these high alloys, a chance to look at this early on, or a budget stage, or really just having someone as a partner that you trust going through your design and helping to really refine it is just a good thing.
Yeah, and just to jump into that, a good example is just recently I was working on estimating a job where a purchasing manager from a company we work with a lot came to me and said, "Hey, we've had you build these pumps in the past and we're looking at a different material." So without going incredibly in depth, I reached out to the vendor that produces the material, saw what they had in stock, saw where some issues were with material availability, and just put together a rough pricing for our customer. But we were able to talk through some material limitations and where we'd have different issues, and he was able to pass that on to their engineers. And they're still looking at potentially going down that route, but at this point now they have a lot better understanding of how easily be able to manufacture it in that grade, and then also just a rough pricing. So there's a good example where instead of fully designing something to an exact material grade before knowing how available it was, they reached out to a manufacturing partner just to get an idea and open the discussion for how easy it is to actually build it.
Yeah, and specifically on the high-end alloys, say you've got a really, corrosive environment and you found some specific, Haynes product or, high nickel cobalt alloy that can withstand the temperature, the abrasion, the strength, and it's the perfect material for your application. But that doesn't necessarily mean that that material has flanges sitting on a shelf, pipes sitting on a shelf, coupling sitting on a shelf, and all these different product forms. So, that's we invest a lot of time, especially with customers that we do regular business with, helping their development and their R&D groups out, helping them with sales quotes and budget quotes on these research and development projects, doing things specifically like Alan was referring to. So it's just a good example of how someone with some experience can maybe guide you right in the right direction a little earlier.
Yeah, those are two excellent examples of material selection when working with a customer. So, Alan, you've been working in manufacturing and preparing drawings for a while now, and in estimating. You deal with tolerance requirements. How do they affect the pricing when specing a job?
Certainly, yeah. And that's a great question. And as I talked about earlier, I actually interned with RV in design engineering for a while. So I kind of started out more on the drawing track. I was the one putting dimensions on. I was the one tolerancing stuff, and still working on grasping a meaning behind that and what I was actually trying to convey with those dimensions. And now I have the privilege of being on the other side, where a lot of the work I'm dealing with is build to print, meaning that our customers coming to us with drawings that are already either finalized or close to being finalized, and we're working on estimating and pricing to build to those drawings. So, as I'm looking over these drawings, the dimensioning, the different tolerancing really tells the story of what is critical and how we're going to build it. A well-toleranced drawing can convey that very clearly and very succinctly, and there's different processes that we need to do in order to adhere to those tolerancing. But at the same time, it can raise a lot of questions. It can cause confusion, and really maybe it causes us to approach it from an angle where we shouldn't be, when there's maybe a tolerance that is far too tight than it should be, or it's maybe just dimensioned in such a way that we maybe can't even inspect it after it's completed. So it's definitely really important to, first of all, stick to a standard title block. So that just really specifies how something is dimensioned, and it brings uniformity to the entire drawing, where it's all adhering to a specific title block. And here at RV, when we produce drawings, we have our own title block, and that is how most companies do that are creating drawings. And it essentially is saying that unless otherwise noted, dimensions will follow this tolerancing. And then as there are changes to that, it can be specifically called out in the drawing, but it really sets a standard for how something is dimensioned.
And to think about on the one extreme, if you're designing something, it would be great if everything could just be held within 5/1000ths of an inch. Why wouldn't it? Why wouldn't you want it to be held that tightly? But the reality is there's cost with every step in increased tolerancing. And obviously that isn't necessary in most applications, but in some industries and applications it is, and that's such a huge role of the designer to tell that story on the drawing and to convey what's important and what's not as important. Not to say that anything isn't important, it's just what isn't as important. Say an overall reference dimension versus a final machined bore where a bearing might sit or a bolt pattern might match up to.
I'm curious, Pete, just listening to you guys, do you have a real life example of an instance where maybe you guys were working with a customer who had a extremely tight tolerance, which affected the project?
Yeah, I mean, a lot of times, especially in, we'll call it maybe some startup companies, they might be giving us a drawing to take a look at to make. And, you know, that initial reaction that we get because, say, there isn't a standard tolerance block on it and everything is in, 2 or 3 decimal place uh, dimensions. And, just an example of that, right? So say something is 1.625 inches dimensioned in 3 decimals. That's, an inch and 5/8. Well, standard schemes would tell you that 3 decimal places means that might need to be held within plus or minus 5 thousandths, and plus or minus 5 thousandths typically mean that's something. If it's a raw shape, it needs to get laser cut, or if it's an overall weldment, it probably needs to get final machined. Um, and because they didn't have a tolerance block, and they didn't say put things in fractional tolerances or mark things as reference, we started heading down a road on cost that just wasn't necessary until, again, we had the conversation with them. We talked to them and tried to understand the assembly and the overall part. And the designer, absolutely knew his component and what it was doing, but we were adding cost onto that part that just was unnecessary because the dimensions that we were seeing based on it being, a 3 decimal place tolerance was unnecessary. And it really could have been what we refer to as a standard fabrication tolerance.
Pete, thanks so much for that example. Another thing that we talk about here is lead time. Could one of you guys speak to lead time and how that can affect the cost of a project?
Definitely, yeah. Lead time is really a critical component in this whole cost structure. Often we'll maybe be having a conversation with a customer or a potential customer, someone that's looking at a new project, and they go over it and we put a quote together and get back to them, and maybe the price looks great, but the lead time can be significantly longer than they might anticipate. And this is often what we run into maybe with someone that's developing something new, maybe hasn't had it manufactured in the past or hasn't really worked with that kind of time frame before. And some reasons for that is initially when we're just having that discussion in the quote stage, so the pricing stage, whenever there's a back and forth or maybe a revision to the quote, a slight change, while that's important and can really hone in on exactly what the customer wants, that always adds time. And you can't really expect a lead time of when a customer presents something to a manufacturer to start the clock ticking right then, because there's definitely that initial build up phase of just looking at it and estimating. And then beyond that, when a price is agreed upon, the customer's happy with it, and a manufacturer receives the purchase order for that job, that there's also quite a few steps that need to happen during that process before something is manufactured.
Yeah, and I think it's us as a sales engineer at the beginning of a project. Maybe we're talking with a purchasing manager, maybe you're talking with a designer, maybe you're talking with a project manager from our potential customer, is trying to understand just out of the gate what kind of lead time they're working with. Because sometimes it doesn't really matter. I shouldn't say doesn't matter, but the project can bear more cost and it needs to get done in this amount of lead time. And that's going to send us down a certain path. And it's not something, you can't ask someone out of the gate to say, hey, what's your budget for this job? That's not something we would ask ethically, or we'd want to know because we want to do our own detailed estimate. But lead time is something that can be shared pretty openly, and it has such a big effect on how we approach a job and manage that.
Certainly, that's a great point, Pete. And that's really a good way, as Pete mentioned, that we can kind of qualify a job or see if we're a good fit for it. and really offer some good feedback initially, because if a customer comes to us, it might be a great fit for us, it might be a great job, but if they say, hey, we want this in 1.5 to 2 weeks, that is going to be next to impossible to produce something unless it is maybe an extremely simple job. But if we can have that discussion up front as to just a ballpark of what they're looking at, we can get a much better understanding and then turn that into an approach for how we want to price it. And, just a look at that is, when we're pricing stuff, we're going out to our vendors, we're looking at lead time from them. How quickly can we receive raw materials before we can manufacture that? Are there other steps such as painting or inspection or different aspects of it that can really add up? So, the better questions we ask early on, we can start to understand what the customer actually needs in terms of delivery.
And, a lot of times customers ask us, say we're people that we build their product lines on a regular basis, what can we do to affect price? And honestly, it might not seem like it from face value, but giving more time to build something really does affect the cost. It makes us say maybe even go after it more competitively because we want, we know we're going to have a little more time to work on it. It's not going to be a rush job for us. And there's, there's overtime, there's expediting both in from our materials and kind of just the burden that it puts through manufacturing that I think it's a kind of an overlooked cost factor. It's easy to say, oh yeah, I need this done in half the amount of time that we originally quoted it in. And, what kind of overtime will you need to get that done in? But even out of the gate, giving consistently decent lead times just has a really big effect on the job, more than I think people might recognize.
Wow, that's a lot of great insight regarding lead time. Now, in your explanation, you gave a lot of examples about the steps that a project takes to go through a manufacturing facility. Could you speak to some of those steps and processes that a project would go through?
Yeah, definitely. Some examples of that are when maybe we need to send that to an outside service. Maybe it's a special kind of coating or plating, or maybe it's a more in-depth inspection, or that those can really add some steps that are just going to add to the lead time of our delivery. Whenever we send something out, we almost always expect, even if it's a simple process in our scheduling, that is probably going to take up a week. It might be a 1 or 2 day process, but turnaround, trucking, all of that can really add up.
Thanks, Alan. Pete, do you have anything to add as far as special processes or steps that you see happen or that you see come through that are going to add to the cost of a project that an engineer or a designer could watch out for?
Alan touched on a couple that can add cost. I would say, I'd spin it around a little differently and talk about some special processes that can, cut costs. Alan, you've worked quite a bit with tube cutting, laser cutting. You want to talk a little bit about your experience in having tubes and structural shapes getting quoted to be done robotically versus, manually?
Yeah, definitely. And that's an important aspect that we try to hit on as, we're a manufacturing company where we do a lot of high-end technical welding, et cetera. But at the same time, we don't always have such a wide technology to have the latest and greatest from every cutting aspect, from, different water jetting, laser cutting, different tube cutting, all that stuff. But at the same time, we can leverage the connections we have with a lot of great vendors that can offer us great pricing, competitive lead times, and all that stuff. So while we might not have everything in-house, we can work with a variety of vendors that can offer what we need for each specific job. So just recently, I was working on a job that had a lot of cutting on some large beams, like 16-inch by 18 or by 8-inch cross section. So really large. We had done a job where our welding department had worked to cut a lot of these by hand prior to welding together. And while it worked great and the job turned out well, as we worked on another design iteration with our customer, we started looking into going out to some different cutting surfaces with local vendors. And we have a good vendor we work with that had just gotten a large robotic plasma cutter, and they were able to cut the beams for the next job a lot quicker. It was significantly cheaper, and we were able to offer, more competitive pricing and a better lead time on that, while at the same time cutting costs. So it's a win-win for everyone, and we can really leverage the good relationships we have with different vendors to offer competitive pricing on that kind of stuff.
Yeah, and the technology changes so quickly. People that specialize in cutting, might have 5 or 6 laser tables, or 1 or 2 tube cutters, or have a structural cutter, and they're constantly investing in that technology, knowing the latest and greatest in it. We're a turnkey fabricator. We don't necessarily want to take up the footprint for two laser cutters. We're not chasing just cutting work. We're chasing projects and unique industrial process equipment that we can support the design and manufacturing of. So that's why, like Alan said, leveraging, our supply chain and the relationships that we have. We don't have to be holders of this technology in one of our buildings when we can work and build relationships and build our supply chain to integrate that into the project.
Certainly. And really, just to reiterate what Pete said, I mean, while this is a competitive industry, and yes, we have, competitors we're trying to beat to get different jobs, et cetera, at the same time, we're really in it together with a wide variety of different vendors. And, we see if we can really double down on what we believe are our strong suits, we can leave other aspects of the manufacturing stage to other companies that are better suited, are bigger, and can maybe, they can focus on their laser cutting, and we can focus on some different aspects of fabrication that we feel we can do really well at. And when you bring it all together, it can offer a much more competitive price point.
Yep, agreed.
Pete, Alan, thank you for that insight. So leading into the next section with welding and fabrication, Pete, you've been a weld engineer at RV Industries for quite some time now. Do you have any advice or tips for designers and engineers when designing a new product?
Yeah, so that's our core competency here as RV is welding. Out of our 160 manufacturing employees, about 95 of those are fabricators, fitters, and welders. So one thing that we see that comes in kind of a full array on a drawing is weld symbols. I feel like that's one place we consistently add a lot of value to designers, and we are always looking to make sure that what they have annotated on the drawing is what they want, be it whether it's a full penetration, whether it's not a full pen. Sometimes we see fillet welds with no size noted on there. Another thing to really think about with welding, if you have any type of quantity that you're designing for, anything over, depending on the size, maybe 10, 20, 30, 50 parts a year even, really trying to look at design for automation. We have a robotic welding system. The cost of automation, the capital cost to put an automated cell in is a lot lower today than it was 10 years ago. So there's really a big opportunity if you can design it with fillet welds, with tab and slot laser cut parts to really bring the cost down to get your part intended for a robot. Anytime you have specialty alloys, we talked about that a decent amount so far today. It's really important to think about the distortion and how that material is going to react to the amount of welding that you have designed into it. We touched a little bit about inspection, but it's just really important to also note, Is this need visually inspected, liquid penetrant inspected, X-ray inspected? And again, all that stuff adds cost, and all that stuff makes sure that your part is done and conforming to how you want it to be manufactured.
Keith, thanks for your insight into the welding processes. Alan, do you have anything regarding machining or a special process for machining?
Yeah, definitely. And this ties in well to when we were talking about dimensioning, tight tolerancing, and that kind of stuff. The reality of it is, for a lot of items that we're looking at that we're manufacturing, they need steps beyond just the fabrication level to accomplish what it needs to do. That might be, a tight finish on a surface. It might need to be parallel to another surface, or maybe it just has a few drilled and tapped holes to mount a bracket to something else. But all of those are generally a great fit for machining. And kind of the different levels we look at that for are we machining small aspects before welding it together, or are we machining it as what we would call as a final weldment? And often we're looking at machining items after it's welded together. And a reason for that is items might move as we're welding them due to heat distortion. Plates might shift slightly, and in order to get everything flat, we need to skim the surface of that. And some important aspects to think about as a design engineer for that are, is this item easy to machine after everything's welded together? And what are the steps as that's being done? So an example of that is, if you have a plate that has a few items welded around it, underneath it, on top of it, and you want a flat surface on the top of that, then you need to look into adding a little extra material onto that before it's welded together, so that when we go to machine it, we take a little bit off of that surface and you end up hitting the dimension you need at the end. And that's often something that we as a fabricator, when we're looking at quoting these jobs, will make sure there's what we call machine allowance to allow for that skim surface, so that when we cut it, it comes down to the dimension we need. But it's always important to have that discussion, and also as a designer to be thinking about those important characteristics on the design stage, because it can really affect how items are machined at the end. And there's really a large topic that you could go into a lot of different in-depth analysis of it. But we have a large machine shop at RV Industries and can handle a wide variety of things, and also work with a lot of good vendors that we can send things out to when we can't hit what we need to do with the job.
Yeah, and that could be like specialized cutting, right? Like EDM, unique 5-axis cutting that maybe, that we don't have the ability to do in-house. We have plenty of supply chain and vendors to support us with that.
Yeah, and without going into too much of a deep dive into this, that's where you can really start to compare costs of fabricating something versus machining. Is it more expensive to start out with a large block of something and cut it down, or is it better to weld on some different geometric shapes to the side of something to hit what you're trying to accomplish as a finished item? And that's where it's just important, if you don't have that experience and understanding, to work with a manufacturer that can answer those questions and at the same time give you pricing on those different options. Because I think as someone that estimates a lot of jobs, that's where I probably see some of the largest volatility or price comparisons between different things, is how you machine something, and if you are machining it, that you add 10 hours of machining to something, it can make a massive price difference. And it's definitely something to be considering in the design stage.
So we talked about cutting, welding, machining, pre-machining versus final machining. How does final finishing affect with the type of material the customer is using?
That's definitely an important question. And a rough breakdown of it is, when you're working with carbon steel, if you don't have any kind of surface finish on it, any kind of paint after it's cut and welded and done, you're going to get rust. And for almost every application, if it's bare carbon steel at the end, it's going to be finished in some way. And then you have your stainless steels, different nickel alloys, and beyond that. And with many of those, they don't require any surface, any paint or any plating. Maybe they're not near susceptible to rusting or different kinds of corrosion, but at the same time, sometimes the paint can really can protect the surface. It might be an aesthetic of it. And then you also have aluminum, where we often work with anodizing things. We send those out to different vendors, or that can be painted as well if it's prepped correctly. But the long and short of it is, almost any fabricated, manufactured item has some kind of surface finish, or at least some kind of post-weld cleaning that gets rid of different contaminations on the surface.
It's great having a partner like you guys who can leverage your own expertise and skilled craftsmen, as well as your vendors. Putting all this together is challenging enough. Now, how do you guys manage a quality program in this environment?
So the quality program or quality requirements of a part kind of start with the industry that it's being supplied into. We have a nuclear quality assurance program. We've got an ASME pressure vessel program. We also have a general fabrication quality assurance manual. And the components that we make all are falling into different types of industries that have different practices. So what we try to do is take the part and the industry that it's in and run that through the quality program, one of our 3 quality programs that make the most sense. They all kind of overlap with inspection processes and procedures and personnel, but the important thing is to consider: are you doing enough to make sure that you're compliant, or are you potentially asking for too much that might be driving the cost up? And we found that it's really helped and it's really clarified when a designer or an engineer is including, say, even the level of documentation, the level of inspection, the type of inspection that they want, the code of construction that they want this built to, all right on the drawing. It takes a lot of the guesswork out for us, and it makes it very clear to what they expect their part to meet when it's done, when it's finished. What code of construction are we inspecting these parts to, say visually or X-ray or liquid penetrant test, and doesn't leave anything up for us to interpret. And they get exactly what they're asking for.
When you're looking for a vendor or for a manufacturer, as a customer, if I were to start seeking out a manufacturing partner for my new project, what do you suggest that people look for when choosing a manufacturing partner? What are the important factors to seek out?
There's definitely a lot of different important areas and different angles to look at it. I would say one of the key concepts is to focus on what is the bulk of the project. Is this a really simple metal item that has a lot of post fabrication processes, whether it's painting or plating or something else, or is this primarily a weldment, or is it maybe just a really high quantity of a simple laser cut item? And all those questions kind of can point you in the direction of what kind of company you want to approach to have this done. And all that being said, I think one thing that really helps us RV industries as a manufacturer in dealing with customers, we're definitely not always the best ones to take on different jobs. And, we can be the first to tell you when it really isn't a good fit. But one thing that really benefits us is we work in a very wide variety of industries. I mean, as Pete mentioned, even just with our quality, there's a lot of different aspects in that depending on the kind of jobs we're working with. So whether it's a simple job without a lot of quality requirements, maybe without a lot of inspection, etc., we can do well with that. It might be a really high-tech job working with a lot of high nickel alloys, different expensive metals that are hard to work with. We can, have experience with that as well. Or at the same time, we can, point people in the right direction to another company. And I even see that that's always a good sign and something I like to see with companies as, I go out to different vendors for applications and stuff. Sometimes they just tell me, hey, we're not a great fit for this, but here's the contact info of someone else that could maybe answer your question. And, that's always something that's good and I think important to look for. If you go to someone that really says they can just answer all your questions and everything's easy and, going on that way, while it might be true, honesty is always the best approach. And when I have someone that can give me a clear answer to something and, tell me whether or not they're a good fit for it and why, I think that really answers a lot of questions and helps me to feel more at ease when I'm going out to different vendors.
Yeah, and to add on that, Alan, I think a common theme of what you're talking about here is trust. And trust and experience with one another. Like you said, it's easy to hear what you want to hear from someone that you gave your drawing to or you're getting a quote from, but building a level of trust with someone is going to pay dividends for yourself and the organization that you work for really for a long period of time. And that, we call it a partner. In this, we're calling it a manufacturing partner. And the idea here is synchronizing, your product line, the developments that you're making with the experience that we have as a manufacturer in, all these different topics. And we've had numerous relationships with customers for decades, in some cases at this point. I think it just goes to show the importance of building that trust and building a relationship and making the opportunity for yourself and us to be successful together.
Yes. Thanks so much for that, Pete. And thank you too, Alan. It's always a pleasure getting deeper insights to industrial fabrication. You were listening to an episode covering synchronizing innovation with manufacturability. Get Sparked is a series of episodes covering unique solutions to complex manufacturing problems. For more information, feel free to reach out to RV Industries online and talk to one of our representatives like Pete or Alan, who you heard from today. Thanks again for joining us.